So we're going to talk about electrosurgery in the context of small animal practice. It's interesting to me that electrosurgery in dogs and cats is much less commonly used than it is, for example, in human surgery. And I think one of the reasons for that is we are generally unfamiliar with the technology. We perhaps are concerned about the safety aspects of the technology, particularly for the patient. And yet it can make surgery more efficient, faster, and indeed safer. So for example, when I talk to people about small surgery, perhaps thyroidectomy in the cat would be an example, it's critical that we maintain a clear surgical field in terms of avoiding blood loss, and particularly in that context, avoiding blood that will obscure what we're doing. And so, for example, electrosurgery is a very good way of keeping the surgical field free of blood so that we can safely do the surgery we need to do. And of course, on bigger surgeries, for example, a mastectomy in the bitch, electrosurgery will reduce bleeding, which is a benefit to the patient. But it will also allow us to move through the surgery more efficiently, because instead of repeatedly placing ligatures, for example, or repeatedly swabbing to remove blood, we can use electrosurgery as we go along to control hemorrhage and reduce tissue trauma and just move more quickly through what we need to do. So that's a starting point on why we're going to talk about this. And then we need to do a little bit of science and machine control in the first segment. And then in other segments, we're going to look at the practicalities of using it, and we'll also compare it to other technologies. So we'll start by considering a standard electrosurgery unit as commonly purchased within small animal practice. And this is the machine we're going to look at here. This is the GIMA 160, which is widely sold in the UK. And it is more than adequate for most people that are only going to do electrosurgery. So we'll look at this. I'm going to get one small point out of the way here, which is an important thing to me. We're going to call this electrosurgery, meaning the application of electricity to divide tissue and provide coagulation. We should avoid the term cautery. Cautery is the application of heat during surgery. But when we use electrosurgery appropriately, the tissue effects we're achieving are through the application of electrical current, not through the application of heat. So let's not call it electrocautery, let's not call it cautery. We can either call it electrosurgery or we can call it diathermy. So having got that small bête noire of mine out the way, let's look at a typical machine and some of the controls on the face of the machine and what it allows us to do. So if we start here, obviously we have the on-off switch. So we'll switch this on for the moment. It's going through a startup cycle. Just refreshing itself here. It's passed and it's ready to go. It's a little unhappy at the moment. We have a flashing light here because we haven't plugged in the patient plate. So I'm just going to plug this in and we'll talk more about this on another occasion. We are. The little red light has gone off. So this machine, in common with most standard electrosurgery machines, has two adjustable functions here. The cutting function and the coagulation function. So cutting function is using an electrical waveform that is designed to divide tissue without excessive collateral damage. And the coagulation function is designed to close and seal blood vessels without cutting the tissue. In other words, if you use cutting in a pure way, you get electrical division of tissue with a minimal amount of collateral damage. If you use the coagulation function, you will seal tissues, but it will not cut the tissue. If inadvertently you choose the wrong mode, then of course you will not get quite the effect you're looking for. So we have cutting and coagulation, and you can see we have dials to affect the power on each of those. But then if you come to this side, you see here we have a number of buttons where we can press, and if we look at these, the first button is on the left hand side of the machine is the cut, and this says here cut. On other machines this would be designated pure cut. In other words, when we've selected this button, then the waveform, the current that's generated by the machine is intended only to divide tissue, for example the skin. The next across, still yellow, 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 and indeed on the handpiece yellow, yellow was always cut. The next button over here, the second yellow one, is designated blend. Now blend uses a mixture of a cutting waveform and a coagulation waveform. So with this it's a compromise. We bring in two types of waveform at the same time, which will produce cutting, but at the same time will produce a little more collateral damage, as it were, and will also produce some coagulation. So what does this mean? If we want to cut the skin, in particular with as little injury to the edges as possible, then we want a pure cut. If we're a little less concerned about some damage to the edges of the skin, and we're more concerned with reducing the bleeding during the cut, then we can go for blend. This is how I tend to use these. So for example, if I perceive there might be a problem with healing, particularly if I'm doing a reconstructive surgery where there may be some tension at the time of closure, I will tend to use a pure cut. But for most general surgery where I do not expect any issues with healing, then I will use a blend, and that's perfectly adequate. People do worry about the effect of electrosurgery on tissue healing, in particular when we're dividing the skin or the mucous membranes. But if we use it in a sensible way, and we'll talk more about this in the practical application, then the clinical effect on wound healing is not important. We can use it safely without having a deleterious effect on tissue healing. So yellow cut, 2 boxes here. Coming across now, we have forced coagulation, and then we have soft coagulation. So these are both for sealing blood vessels, either large or small blood vessels. The forced coagulation is what we use most commonly, and this produces a current form that is intended to cause tissue or protein coagulation, and therefore sealing of blood vessels and bleeding points. And we'll look at how we use this. The soft coagulation tends to be used in a slightly different way, so we could use that almost to spray the surface of exposed tissue with electricity, and therefore produce a change across the exposed surface. So we could use that to control a number of bleeding points, or it can be used to destroy their surface layers. That's something we would rarely consider doing in our patients, but we could imagine perhaps you've removed a mass in the mouth on the gum and you're unable to close the mucosa, but you want to stop the exposed surface bleeding. Then you could use soft coagulation in a sort of spray mode across the surface to destroy any remaining neoplastic tissue, and at the same time to control any bleeding points. But it's not something we normally do. So we would normally choose the forced coagulation. And then finally, if we come across here, there's one more button here, which is bipolar. So now let's talk about the difference between monopolar and bipolar, and have a look at some of the tissue currents.